phases in product design and development. If you want to launch a new product, we need to follow these 9 steps. Step 1, idea generation. We need to create new idea about the product. Then we need to do feasibility analysis. It means that it is possible to launch this new product or not. So we need to consider in terms of the cost, profit of launching this new product into markets. After that, if it is good profit, good return on investment, we go to step 3. We do the product specification. We decide the product spec, like how big is the new product, what is the weight, what are the raw materials that we're going to use for the new product. Step 4, we decide the process specifications, like what technology, what machines we're going to use to produce the new product. Step 5, prototype development. When we make the new product in the beginning, so we just make some samples, maybe only 1 or 2 samples, and then we need to taste the samples, whether we are satisfied with the samples or not. Step 6, if we are not satisfied with the samples, we need to revise or change the design of the new product and then taste again until we feel satisfied. Step 7, when we launch the new product, we need to do the market test first to see what the feedback from the customers. Step 8, after we know the feedbacks from the market test, then we can launch our new product nationwide. However, the last step, after we launch the new product nationwide, we need to follow up, control and check, do we still have any other problems that we need to fix. Let's see the details of each step. Idea generation, the first step. The ideas of new products can come from 3 sources: supply chain based, competitor based, and research based. Supply chain based. Ideas of new products can come from anywhere in the supply chain, can be from our customers, suppliers, distributors, our own employees, especially those maintenance and repair personnel. They can have a good suggestion about new products. Second source is a competitor based. By studying how a competitor operates and its products and services, many useful ideas can be generated. We have the term reverse engineering, like we buy our competitor products and then we dismantle and inspect the competitor product and discover what they use, what are components inside, and we can make our products or even make it better than competitors' products. Research-based. Research-based is like organized efforts to increase the scientific knowledge of product innovation. Like for example, in big companies, normally they have laboratories, so we can discover new products from those laboratories, so we can apply those results to make new product. We call research-based. Designing for manufacturing. This is a good idea for this one. Beyond the overall objectives to achieve customer satisfaction while making a reasonable profit is design for manufacturing, DFM. So designer needs to consider the company's manufacturing capabilities when they design the new product. For example, do they have machines, do they have technologies to produce a new product? Are there workers, do they have skills to make the new product or not? Concurrent engineering. Also, it's good when we design new product. Concurrent engineering is bringing engineering design and manufacturing people together early in the design phase. We also involve marketing and purchasing people because marketing people, they know what customer want, and purchasing people, they know what raw materials they can find from the market and what raw materials are expensive or cheap. We also get comments or views from suppliers and customer. Computer-aided design. Today, when we design new product, we will use computer software to help design new products. It's good and provide a lot of convenience because it's increased productivity, and when we change the design, it will be easy to change, to revise. Production requirements. Designers must take into account production capabilities. As I said earlier, they need to consider their companies, like do they have machines, equipment to produce? How about their workers? Do they have skills? What types of raw materials they need? How about the schedule for the manufacturing? And how about technologies in their factories? Do they have those technologies or not? Manufacturability. It's easy to fabricate or to make and to assembly. So designer need to consider this as well. Make it easy to produce the parts and easy to do the assembly, combine all the parts. If we can do that, product cost will be lower, higher productivity, and we get good quality. The next four slides, we focus on the 3R. Those will be to save the environment and save the natural resources. The first R is the reduce. We focus on cost and raw materials. Look at the term value analysis. Examine the function of parts and materials in an effort to reduce the cost and improve the performance of a product. So we better ask ourselves some questions. For example, can we use a less expensive part or raw materials, but the quality is still good quality? And is the function or are those functions necessary to customer or not? If not, we may reduce those functions from our product. Can the function of 2 or more parts be performed by a single part? Or can we make a part like more simplify the parts? Second R is the remanufacturing or reuse. This is refurbishing used products by replacing worn out or defective components. For example, in the market today, you can look at we have second-hand cars or second-hand computer notebooks. This is reused products. What are the good points? For example, remanufactured or reused products can be sold for 50% cheaper, and we can use unskilled labor. And some countries, the government will require companies to do reuse or remanufacturing if you want to do businesses in those countries. So we have the term design for disassembly, DFD. Means designing products so that they can be easily taken apart. When we take back the used product or the old product, it will be easy for us to separate the parts. The third R, recycling. Recycling is a recovering material for future use. We take back the used product and we may melt down some paper, we melt down some plastic or some metals and use those results to produce other products. Recycling reasons cost saving. If we can do recycling, we can save our cost because we can use the old raw materials We just melt them, transform them. Environmental concern, we save the natural resources. And environment regulations mean other countries, the governments will force you, will let you do this if you want to do business in those countries. How about component commonality? So when products have a high degree of similarity in features and components, a part can be used in multiple products. Like for example, GM cars, they have like some parts they use in the different models. For example, braking system, water pumps, and so on, safety belts. So they can use some parts in several models. What are the benefits? Saving design time. Let me just design one water pump, so we save the design time. Standard training for assembly and installation, so easy to train our workers because those parts, they are the same. Opportunity to buy in bulk from suppliers, so we get discount, cheaper prices. Commonality of parts for repair, and we keep fewer inventory items.